Hello everybody, I am going to go ahead and teach you the next lesson today. So we're going to do lesson 2.9, proving parallel lines. So like we've talked about before is conditional statements and converse statements. So a conditional statement says if P then Q. Right? So if P then Q, where P and Q are two different statements. Whereas the converse is if Q then P, right? It switches the order of them. So up until this point, when we've been proving things, we've been working with conditionals. So today we're going to work a little bit with converses. And so we are going to use the converses of theorems from lesson 2.7 to prove lines parallel. So again, the last lesson that we did, we talked about how, okay, if I have two parallel lines, then these angles are congruent. Today we're going to go the other direction to prove that two lines are parallel. So the first one we're going to talk about is the converse of corresponding angles postulate. So again, that's our first converse. Excuse me. So the corresponding angles postulate says if we have parallel lines, then corresponding angles are congruent. Whereas this one says if two lines cut by a transversal so that corresponding angles are congruent, then the lines are parallel. So we're going kind of the other direction. So what that means for this example is if, say, one set of corresponding angles, angle 1 is congruent to angle 3. Right, so we say angle 1 and angle 3 are both in the upper left-hand corner of those lines. Now, we also could have used other angle pairs that are corresponding, like angle 8 congruent with angle 6, angle 2 congruent with angle 4, and angle 7 congruent with angle 5. So if those are true, then we can say that line A is parallel, and we use those two lines to denote parallel, to line B. So if those two are congruent, we can then say these two lines are parallel. Alrighty. So we can do this with other angle relationships too. So again, we have like the converse of the alternate interior angle theorem. So if this says if we have two lines cut by a transversal, again, note it didn't specify that these lines are parallel. That's what we're trying to prove. And we have a pair of alternate interior angles. If they are congruent, then again, we can say that the lines are parallel. So in this situation, if angle 6 is congruent to angle 8, then line P is parallel to line Q. Again, angle 6 and angle 8 are those alternate interior angles. If those are congruent, then these two lines are parallel. We can also do something similar with the same side interior angles. So if two lines are cut by a transversal so that a pair of same side interior angles are what? What do we think same side interior angles need to be? They need to be supplementary, right? These are that one special pair where they're not congruent. Instead, they are supplementary. Then the lines are parallel, right? We have these two angles here, angle 4 and angle 5. They are same side interior angles. So that means if the measure of angle 4 plus the measure of angle 5 is equal to what? What does supplementary mean? It would be 180. Then that allows us to say, okay, line P is parallel to line Q. So again, that's the one situation where we don't want them to be congruent. We want them to be supplementary. And then our last converse is if two lines cut by a transversal so that a pair of alternate exterior. What do we need these to be? They do need to be congruent. So if this is congruent to this, these are alternate exterior because they're outside of the parallel lines and on or outside of the lines and on opposite sides of that transversal, then we can say the lines are parallel. So in this case, if angle 1 is congruent to angle 3, then we can say these two lines are parallel. P is parallel to Q. Alrighty, let's do some practice with it. Okay, so in this image, we're given that angle 1 is congruent to angle 6. And we want to be able to say, okay, what two lines are parallel and why? So we see here that P is our transversal, so that can't be our parallel line, right? It should touch both of them in order for it to be a transversal. And so we see kind of one of our lines is here. This is line L, and we see that the other line here is line N. So we're allowed to say that line L is parallel to line N, and it's asking us why are these two lines parallel. So we want to say, okay, we're working with a converse, right? Because that's how we prove parallel, not using a regular statement, but a converse. So it's going to be a converse of, and then what angle relationship is that? So those, again, are outside of those lines and on opposite sides of the transversal. So that's going to be that alternate exterior angle theorem. So again, we're kind of going backwards here. So then we want to do it again, and we want to say, okay, angle 2 and angle 3. So again, that P is our transversal, so it's not going to be it's not going to be P. And then we're looking at those parallel lines, or lines we want to prove parallel. So we see this line here, and we also see this line here that's touching one of those angles, right? So that means that line L can be parallel to line M, and then we want to state what by. And so those angles are alternate interior angles, but again, if we're proving parallel, we want to say the converse of the alternate interior angle theorem. Alrighty. Excuse me. So let's go to a bit more complicated image. So we have a lot of lines happening here, and we want to figure out which lines are parallel and why. So we're starting with 2 and with 8. So the first thing you may want to do is establish, okay, what is my transversal? So my transversal is going to be the line that touches both of these angles. So in this case, L is my transversal, so that's not what I'm proving parallel. And then my other two lines should only touch one of the two angles. So here we're trying to prove that angle A is parallel, line A is parallel to line B. And then we want to figure out their angle relationship. Again, if we're proving parallel, we want to say by, and that's going to be by what? What do we think? It's going to be by the converse, again, because we're proving parallel, of the alternate interior angles theorem. Again, because we're talking between these two parallel lines and on opposite sides of that transversal. So sometimes it's nice to be able to highlight those lines if you like, or just get kind of just a pencil and go over top of them just so you can kind of see the image a little better. So the next angle relationship we're talking about is angle 3 and angle 11. So again, the line that they're both touching, that's going to be the transversal. So that means that A here is our transversal. So that's not what we're proving parallel. The other two lines, the ones that only touch one of these, that's what we're trying to prove parallel. And so that's going to be these two. I am going to erase my little arc marks here just so as not to confuse you guys. But if you leave yours, that's fine. We would do maybe like 2 arcs for these. And I'll go back and leave them. Okay. And so this time we're trying to say that L is parallel to M. And we want to say by, again, it's a converse. And then we want to say, okay, what is that angle relationship? This one's maybe a little bit different, but they're both in the bottom right position. And again, they are congruent. So that's going to be the converse of the corresponding sorry, I'm running into that, angles, and it's the angles postulate instead of theorem. Alrighty. Okay, next one. What two lines do you think are we proving parallel? Okay, so if we have 12 and we have 14, and we know that they are congruent to one another, again, we have this transversal, that's the one that's touching both of them, and then these would be the two lines we're attempting to prove. So these two angles are outside of those two lines, and they're on opposite sides of that transversal. So we're trying to prove that line A is parallel to line B, and they are by the converse, again, we're proving parallel, of the alternate exterior angles theorem. Because they're on opposite sides of that transversal, and they're outside of those two sets of lines. Alrighty. Next set. Okay. So we're looking at angle 1 and angle 15. So one thing we may notice about this is these don't share a transversal. And so that's a problem. So because these don't share a transversal, we actually don't have enough information to make any conclusions. Right, all of these theorems that we've been working with say if two lines are cut by a transversal. That's how they all start. With this one, these two angles, we don't have two lines cut by a transversal. They don't share a line. So we don't have enough information to prove that there are parallel lines here. There may be, we just aren't given enough to say that. Alrighty. And then we have angle 8 plus, the measure of angle 8 plus the measure of angle 13 equals 180. So I'm not going to put arc marks here because these aren't congruent, but we know that 8 plus 13 is equal to 180. We know that they're supplementary, right? So we see that those two angles, again, they do have a transversal, right? They both share this line here, and then they have a line here and a line here as well. Okay? So, excuse me. So we have this, and so they are on the same side of that transversal, and they're in between the two lines. So we can say that these two lines, L and M, are parallel. L is parallel to M. And again, that's by a converse. Anytime we're proving parallel, that's by a converse. And that's going to be the converse of the same side interior angles theorem. Okay, and we have one more. We're looking at angle 6 and angle 8. So we're looking here. I'm going to draw a lot of arc marks. I don't know if that's enough, but we're looking at these two angles. Now, what type of angles are these two angles? If you said vertical, you're right. The problem is we don't have any vertical angles theorem that can say we're proving any lines parallel. So these, technically speaking, have like two transversals, right? Because they share two sets of lines. So because of that, there's just not enough information here. There are no lines that are proven parallel here. So there are no lines proven parallel. You also could have said not enough info, and I would have taken that as well. But they're vertical angles. We don't have a vertical angles theorem that allows, vertical angles are congruent, but we don't have a vertical angles theorem that allows us to say that lines are parallel. Alrighty, we've got a few more problems, but it's a pretty short lesson. So this says find the measure of MRQ, so that angle I'm sorry, so that line A is parallel to line B. Identify the postulates or theorems that you used. So this is a little hard to see, but this is referring to this angle. So we're looking at angle MRQ, so that's this one. And we want to prove that line A is parallel to line B. So in order for line A to be parallel to line B, that means these two angles need to be congruent, right? The measure of angle MRQ needs to be equal to the measure of angle RPN, right? So in order to prove these parallel, that has to be true. And we'll state the theorem that we used a little bit later. So for right now, we can go ahead and set these measures equal. So we can say 5x plus 7 equals 7x minus 21. We'll subtract 5x from both sides. Oh, sorry. And add 21 to both sides. So we're going to get that 28 equals 2x, and then we'll divide by 2. So we're going to get that x is equal to 14. Okay, but we're not quite done yet, because it wants us to say, find the measure of this angle. So we need to go back and we need to plug into measure MRQ. Now, does it actually matter which one we plug into? No, because they're congruent, so we can plug into either. But I am going to plug into the normal one. So we'll do 5 times 14 plus 7. 5 times 14 is 70. 70 plus 7 is going to be 77 degrees. And again, we want to state the postulate or theorem we used. So we've proved these two lines are parallel if this angle is 77 degrees by the converse of, and we're working with alternate interior angles here. Alrighty. Alright, we've got a few more. So the next one we're talking about is we want to prove that E is parallel to F. So we may be looking at these two angles right now, and we have this right here, and we're also looking at this angle here. Now, as is, these two angles don't actually have a relationship, right? One is, they are on opposite sides of that transversal, but one's in the interior, this one, and then one's in the exterior, this one. And so because of that, they don't really have a relationship. However, we can say that if this is a right angle, then that means these lines are perpendicular, so this has to also be a right angle. You also could have said, well, this also needs to be a right angle. There are plenty of options there. Regardless, we know that all of these are right angles, so we can say that in order for these to be parallel, 4y plus 10 would have to equal 90. So then we'd subtract 10 from both sides, and we get that 4y equals 80, and divide by 4. So in order for these to be parallel, y needs to equal 20, but again, we want to state our reasoning. It's going to be by the converse of, and again, you could say a few things. If I picked, that angle, then I would say like alternate exterior. If I picked this angle, then I would say corresponding. There's lots of options. So I am going to pick this one, and I would say the converse of the corresponding angles postulate. Excuse me. Alrighty. We have one more. So this is number 5, and it says, what values of x and y makes r, s, and t parallel? So typically when we do something like this, I would work on one transversal at a time. So we're looking here, and we see that we have this transversal. So I'm really focusing on the two lines where I have measurements. So I'm looking at R and S first. And I have these two angles here. So we see that these two angles are corresponding. And so in order for R to be parallel to S, these two need to be congruent. So that means that 3x plus y needs to equal 82. Okay? Because that is going to make R parallel to S by the converse of the corresponding angles postulate, for the sake of space. Okay, so that's giving us that. And then if we're looking at the other transversal, this one right here, we're talking about R, and we're talking about T this time, because those are the two that have angle measures attached to them. So we see here that R has 62, and T has 5x minus y. Now the problem is right now, they are on the same side of the transversal, but they are both in the exterior of these two lines, which we don't really have a theorem for same side exterior angles. However, these are vertical angles. So if this angle is 62, this angle would also have to be 62. And if this angle is 5x minus y, then this angle also has to be 5x minus y. So now we should hopefully see, okay, now they are between the two parallel lines, these two, and they're on the same side, so they are same side interior angles. So in order for this to work, these two need to be supplementary. So that means that 5x minus y plus 62 has to equal 180. That has to be true in order for R to be parallel to T by the converse of, excuse me, I lost my train of thought, I'm sorry, by the converse of the same side interior angles theorem. Again, we also had to do some vertical angles there to make that work, but that's how we get there. So then we have a system of equations. So one thing I'm going to do is I'm going to subtract 62 from both sides to help me solve this. So I'm going to have 5x minus y equals, and we'll do 180 minus 62, which is 118. Yeah, okay. And then I'm going to bring the other equation down. So I have 3x plus y equals 82. So one thing we should maybe see here is that we can add straight down, and when we do that, the 5x plus 3x is going to become 8x. Sorry, 8x. The y's are going to end up canceling, and we're going to get that 8x equals 200. So then we can divide both sides by 8. And we'll get that x is equal to 25. Okay. Excuse me. So it's great that we got that x equals 25, but we still need to find the value of y. So it doesn't matter which equation you plug back into. I'm going to plug into the top one, and we'll say 3 times x, which is 25, plus y equals 82. So 3 times 25 is 75, plus y equals 82, and then we subtract 75 from both sides. So y is going to equal 7. So in order for this to work, x has to be 25, and y has to be 7. And that is where we will end the lesson for today. Thanks, guys. Make sure to do your homework.